Guys, Mrs. Levenseller here, and we're just going to make a quick little video on 2.3. Now we're working on solving two-step equations. So your learning target, very similar to the title, I can solve a two-step equation, learning target 2E. So in the first video, we talked about all the rules and the reasons behind solving equations, right? All those same rules apply, we just now have to do more than one operation to solve our equations. So let's talk through these rules quickly. First rule, whatever we do to one side of an equation, we have to do to the other, right? And remember, that's because of that equilibrium. We have to keep it balanced. All right, so anything you do to the left side of the equal sign, you have to do to the right, and vice versa. Second, when our goal is to isolate the variable, and we want to do that using opposite operations. So if you remember, those are adding and subtracting, multiplying, and dividing. As we get a little fancier, there will be a few more operations, but for now, that's what we need to focus on. And then, third, when solving, we're still going to use PEMDAS, just like when we simplify an equation, an expression, but we're going to reverse it to solve, okay? So we're actually doing SADMEP, if you can reverse that. The only difference here is, for most of these problems, we are going to add and subtract things away from the variable first, and then second, we will multiply and divide. But sometimes we end up with, and I don't want to say parentheses. Remember, we talked about P as representing any sort of grouping. So it might be a fraction bar, it might be parentheses, something like that. But oftentimes when we're solving, we actually have to undo the grouping first before we can add or subtract pieces from that. So we have to be careful of what's actually happening there, but we'll look at a few examples like that in a minute. So example 1 is negative 22 is equal to negative 8 plus 7y. So our goal is to isolate the variable, so I'm going to try and get y by itself. And first we said we want to add or subtract any numbers away from the variable. Now it's not to say you have to do that first, but if you went ahead and divided the 7 by everything, then you end up with more fractions, and that just makes it more complicated for you. So I would always suggest, if you can, add or subtract a number away from the variable. Well, negative 8 is on the same side of the equation as the variable, so we would consider that close to the variable. So we have to move it to the other side, and I'm going to do that by doing its opposite. So if it's negative 8, I'm going to add 8, and whatever I do to one side, I must do to the other. Okay, so that's the addition property of equality. Now, negative 22 plus 8 would give me negative 14, right? So actually combine those there, equals, and then the only thing left on the right-hand side is 7y. So that was our first step, was to add 8. Now, to solve, our second step is to totally isolate y by getting rid of 7. And remember, the operation there, if we don't see anything, is implied multiplication. Well, the opposite of multiplying is division. So I'm dividing both sides by 7. And that's your division property of equality. So negative 2 is equal to y. And standard convention likes us to have the variable on the left. So we could write it as y is equal to negative 2. Okay? If you want to check your work and make sure that you got the answer correct, you can always take this answer and substitute it back in for y. So we could say negative 22 is equal to negative 8 plus 7 times negative 2. And then simplify everything on the left and everything on the right. So here we have negative 22 is equal to negative 8 minus 14. PEMDAS tells us to multiply first. So negative 22 is equal to negative 22. As long as both sides equal, you solve the equation correctly. All right. Let's look at the second example. see if we can follow this one. So 15 plus q divided by 6 is equal to negative 21. We want to solve for q. We're always trying to isolate the variable. And the first step is to add or subtract values away. Well, since 15 is on the same side of the equal sign as q, I need to get rid of that by subtracting it. Because it's positive, the value in front of here is positive, that means that I want to, that looks a little misleading, that means that I want to subtract it. All right, so 15 minus 15 cancels. We're just left with q divided by 6. And then on the right-hand side, we have negative 21 minus 15, which would be negative 36, right? So we end up with q divided by 6 is equal to negative 36. And then our second step, if we want to isolate the variable, is to undo either the multiplication or division. Well, this says q divided by 6. The opposite of dividing would be multiplication. So I'm going to multiply the left-hand side, and whatever I do to one side, I must do to the other. So we get, when we have 6 times q over 6, you can think of that as 6 over 1. So what really happens there is that the 6's can cancel out. So we're just left with q, and then on the right-hand side, we get negative 36 times 6, which would be negative 216. Again, if you want to make sure you're correct, take your answer, substitute it back into the original equation, and double check your work. So 15 plus negative 216 divided by 6 is equal to negative 21. Well, that would be 15 minus 36 is equal to negative 21. So negative 21 is equal to negative 21. Checks. All right. Then we get to example 3, and this one looks a little different. Remember, we talked about the division bar acting like a grouping symbol, right? It's breaking 7 plus 6 and the 3 into 2 separate components. So this is the one place where we had to actually break our rules a tiny bit, right? Instead of completely reversing PEMDAS, we're going to start by undoing the grouping first. And in this case, the grouping is division, right? It's this division bar here. So the way that I would undo that is with multiplication. The opposite of dividing is multiplying. So I'm going to multiply by 3, just like we did in the previous problem, right? We had dividing by 6, so we multiplied by 6, canceled them out, because 6 over 6 is 1. Divided by 3, so I'm going to multiply by 3, and whatever I do to the left side, I have to do to the right. So 3 and 3 cancel, so that just leaves me with z plus 6, technically over 1, but when we write something over 1, that's the same as itself. So I'm not going to write that to make it easier on myself. So just z plus 6 is all we have left. And on the right side, that would equal 24. Okay. And then we know z plus 6 is equal to 24. Well, if I want to isolate the variable, again, I'm still trying to get z alone. If it's plus 6 on the same side of the equal sign as z, then I would do a minus 6 to both sides. So z is actually equal to 18. All right. Again, check your answer if you want to make sure you're correct by substituting 18 back in for z. Let's do that one more time by dealing with x plus 3 divided by negative 2 is equal to 10. So I'm going to undo the grouping first. And I undo that. Well, again, we see division. So I'm going to undo it with multiplication. And whatever I do to the left, I have to do to the right. Negative 2 and negative 2 cancel. So I'm left with x plus 3. And on the right-hand side, I have negative 20. So the last step to isolate the variable to get x alone is if I have a plus 3, do the opposite. So that would cancel out those 3's, and then we just have x is equal to negative 23. All right. So a few steps here to actually get the answer. And remember, you have not solved an equation until the variable is totally by itself. Okay, so if you're still left with 3x equals 15, or x plus 1 is equal to 10, if there's anything next to the variable, you have not solved. You're not done until that variable is totally alone. Okay, so take some good notes here, write down these examples, and then give 2.3 practice set